Hola Chiquitas. So today I will be doing number 41 for chapter 5 AP Physics 1 homework. So it states that a 2.1 times 10 to the third kilogram car starts from rest. Sorry, I didn't show you the question. Starts from rest at the top of a 5-meter long driveway that is inclined at 20 degrees with the horizontal. So drawing our diagram, we know that there is a 20 degrees slope. We have a car here, and its displacement is 5 meters this way. And it says that the car has a frictional force of 4.0 times 10 to the third newtons. So drawing the forces acting on the car, we know that its weight, mg, is here, and friction is acting upon it here, and our friction was 4.0 times 10 to the third newtons. Oh shoot, it's cut off. I hope that you guys saw all of that. And to find the x and y components, we can draw a little thing here, and we know that this 20 degrees corresponds here. So right here would be our mg sine 20, and this side would be our mg cosine 20. So first we need to find the sum of forces, and before we do that, I forgot to mention we should make this our positive y direction and this our positive x direction to make things easier in the long run. So first, to find our sum of forces, we use our basic equation, F equals ma. So we know that we have in our x direction, we have our mg sine 20 right here. And we subtract friction because it's going in the negative x direction. And our friction is 4.0 times 10 to the third newtons. And that equals our mass times acceleration. And our mass given was 2.1 times 10 to the third kilograms times A. That's an A. So if we plug this and simplify it, we get A equals mg sine. Anyways, going on where we left off, we can simplify this equation to say acceleration equals our mg, which is 2.1 times 10 to the third times gravity, 9.8 meters per second squared, sine 20 minus our 4.0 times 10 to the third newtons, and I have no room to write that, so I'm just going to draw an arrow there, and we can put that all over 2.1 times 10 to the third kilograms. And once you solve this, you should get the acceleration equaling 1.45 meters per second squared. So we can write this off to the side here, that our acceleration is 1.45 meters per second squared, because now I need a tissue and we need to plug this into a kinematic to find our final velocity, which is what the question is asking for, the speed of the car at the bottom of the hill. So we can use the kinematic Vf squared equals Vi squared plus 2ax, and since the car is starting from rest, we can automatically assume that this is 0, so we have Vf squared equals 2 times our acceleration, 1.45 meters per second squared, times our displacement, which is 5 meters, and by doing this, we should get our Vf squared equaling 14.45, but of course we need to square root that, so sorry, I'll write my steps down. So our VF equals 3.8 meters per second. Boom.